The heights in 2011 of Irish males born in 1992 are normally distributed with a mean of 178.8 centimetres and standard deviation of 7.9 centimetres. Part 1. Use the empirical rule to complete the following sentence. 95% of 19-year-old Irish men are between something and something in height. So they are between 163 centimetres and 194.6 centimetres in height. Okay, so where did these numbers come from? So for 95%, to get this interval, using the empirical rule, we're going to have the mean, so x bar means the mean, minus 2 times the standard deviation, so that's not a 6, it's a symbol for standard deviation, comma, the mean plus 2 times the standard deviation. So the mean is 178.8 centimetres. So we're going to subtract 2 times the standard deviation, which is 7.9 centimetres. And 178 minus 2 times 7.9 is 163. And then we have the mean plus 2 times the standard deviation. So again, the mean is 178.8. So this time we're adding 2 times the standard deviation, again, which is 7.9. And 178.8 plus 2 times 7.9 is 194.6. So, using the empirical rule, 95% of 19-year-old Irish men are between 163 centimetres and 194.6 centimetres in height. So, in this question, we were given the mean and we were given the standard deviation, but in other questions, you could be asked to work out the mean or to work out the standard deviation. So you can have a look in the playlist called LCOL Statistics to find videos on how to work out the mean and how to work out the standard deviation, because this can come up in a different question. Part 2. Use the empirical rule to make one other statement about the heights of 19-year-old Irish men. So this is our normal distribution curve. So it's a bell-shaped curve. And the numbers at the bottom, so minus 3, minus 2, minus 1, 0, 1, 2, 3, they all represent standard deviation. So in our question, we were asked about 95%. So we see 95% stretches across to 2 and to minus 2. So if the question asks for 95%, then you add 2 times the standard deviation to the mean, and you subtract 2 times the standard deviation from the mean. If it said 68%, you would add 1 times the standard deviation, so basically just add on the standard deviation to the mean, and subtract 1 standard deviation from the mean. And if it said 99.7%, you would add 3 times the standard deviation to the mean, and you would subtract 3 times the standard deviation from the mean. So, in any normal distribution, approximately 68% of the population lies within 1 standard deviation of the mean, i.e. 68% lies within the range x bar minus, so x bar representing the mean, minus 1 standard deviation, comma, the mean plus 1 standard deviation. So this is for 68%. So it's 1 standard deviation that we add and subtract to the mean. Approximately 95% of the population lies within the range mean minus 2 times the standard deviation, comma, the mean plus 2 times the standard deviation. So this is for 95%. So you subtract 2 times the standard deviation from the mean, and you add 2 times the standard deviation to the mean. And approximately 99.7% of the population lies within the range mean minus 3 times the standard deviation, comma, the mean plus 3 times the standard deviation. So for 99.7%, it's the mean minus 3 times the standard deviation, comma, the mean plus 3 times the standard deviation. So this is given to you in the formula book. Where we see the standard deviations at the bottom. So there is a similar curve in your formula book. But these numbers, the percentages, you would have to learn off. But these are the only 3 percentages that can come up. So 68%, 95% and 99.7%. And it's always 1, 2 or 3 standard deviations. So use the empirical rule to make one other statement about the heights of 19-year-old Irish men. Well, we can say that 99.7% have heights between the mean minus 3 times the standard deviation, comma, the mean plus 3 times the standard deviation. So the mean, again, from the previous slide was 178.8. And the standard deviation, again, was 7.9. They were given in the question. So 178.8 minus 3 times 7.9 is 155.1. And then the mean plus 3 times the standard deviation is going to be 178.8, which is the mean, plus 3 times 7.9, which is the standard deviation, and 178.8 plus 3 times 7.9 is 202.5. So 99.7% have heights between 155.1 centimetres and 202.5 centimetres. Likewise, we could have said 68% have heights between the mean minus 1 times the standard deviation, or minus 1 standard deviation, comma, the mean plus 1 standard deviation. So again, this is all coming from our curve. So again, the mean is 178.8 minus the standard deviation, which is 7.9, gives us 170.9. And then the mean, 178.8, plus the standard deviation, 7.9, gives us 186.7. So 68% have heights between 170.9 centimetres and 186.7 centimetres. So either of these will do. D. The male students in Part B are a sample. The males in Part C are a population. Is this a suitable population to compare the sample to? Give a reason for your answer. So to be honest here, you can answer yes or no. You could say yes, it is suitable because they are the same age. But you could also say no, as it's a small sample. So either yes or no will do, but you must have a reason to back it up. E. Would you say that the males in the class are taller, smaller, or about the same as the population? Use the data to justify your answer. And the answer would be smaller. So the mean height of the males in the class is 175.5 centimetres. So this would have actually been got in a previous question. So this is only Part C of the question. But the mean height of the males in the population is 178.8 centimetres. So this was given to us in Part C.